Welcome back, ladies and gentlemen. Today we're going to be discussing how we solve something known as a rational equation. So some of you may not exactly know what a rational equation is. So let me explain that real quick before we actually start trying to solve them. Okay, a rational equation. Let's see, rational. A rational equation is an equation where the variable is in the denominator. It might look something, uh, I don't know, maybe 1 over x is equal to 10. That is a rational equation because the variable that we're looking for is in the denominator. Now keep in mind, that is a relatively simplistic version of it, but it fits the concept, it fits the idea of what a rational equation is. And we're going to be doing a lot more with rational stuff in the future, particularly when we're dealing with functions. Now, pay attention to what it says in the second part here. You must exclude solutions that would make any of your denominators 0. That is really important because that would create something that is undefined. Now, we have a little bit better idea of what that's called here. Oh, I'm sorry, I'm just not paying attention. Uh, Anything that would create a 0 in the denominator is known as an extraneous solution. Okay, so anything that would make your denominator 0, that is known as an extraneous solution. Algebraically speaking, sometimes we will get something that looks like it would be a good solution, but if we plug it back into the original problem, it would give us a 0 in the denominator and therefore be known as an extraneous solution, meaning it looks like it works, but it really does create something that's undefined. So here, this is going to be, unfortunately, probably one of the easier problems that we're going to see in this example. Guys, I gotta tell you that rational problems of any kind do cause some algebraic problems for students because it does require some pretty good algebra skills. Students that are in pre-cal typically see this during the algebraic portion. This is one of the earlier things that they tackle. And even in that class, whether it's a regular class or a pre-AP class that I've taught, it is a skill that can be challenging for students. Now, this particular rational equation is pretty basic because at its most fundamental level, it's really just a proportion where we can solve by cross multiplying. So I'm going to take the 4 and multiply it to everything here, and take the 7 and multiply it to everything here, and see what we wind up getting. So 4 times 3y gives you 12y, and minus 20 to be equal to 14y minus 21. And now we're going to solve for y. First, isolate your variable, and since the 12 is smaller than the 14, oops, I'm going to move that one, so those cancel. That's 2y. So I have negative 20 is equal to 2y minus 21. Move the 21 over through addition, and that would give you 1 is equal to 2y, so y is equal to 1 over 2. Okay, now is that a solution? Okay, how do I know what an extraneous solution is? So let's check for those. Check for extraneous solutions. The way I do that is I'm going to take whatever the denominator is, 2y minus 3, and I'm going to set it equal to 0 for both anything that has our variable in the denominator. So I have to do it for the other one as well. So 3y y minus 5 is equal to 0. So if I solve either of these expressions for y, here 2y will be equal to 3, so y would be equal to 3 over 2. And here 3y would be equal to 5, so y would be equal to 5 over 3. These are the two things that would be known as extraneous solutions if they showed up in in the solution when we worked the problem out originally. These are what would cause the equation to become undefined. And anything that is undefined really doesn't have a proper solution. So in this case, the actual answer is y is equal to 1/2. However, if y had equaled either 3 over 2 or 5 over 3, then we would have said, well, it looks algebraically like it'll work, but technically it's extraneous. Now here, unfortunately, most of these problems we can't do cross-multiplying with. So in order to be able to solve it, since the variable is in the denominator, we have to take it out of the denominator. And the easiest way of doing that is kind of like what we did before with a lowest common denominator. Very similar to the types of equations like a linear equation where we had to just get rid of the fractions completely. Unfortunately now, the fraction actually contains the variable in the denominator that we're solving for, and it does unfortunately have a tendency to increase the difficulty level. I'm not trying to say that to cause any concern, but I definitely don't want to sugarcoat anything. Now here in the problem, we have 10 over x minus 5. Since the variable is in the denominator, that automatically creates a rational equation. And what that means is we have to identify, well, what is the lowest common denominator? So lowest common denominator. Since the denominator of the problem, the 10 has a denominator of x minus 5, the x has a denominator of 1, so that really doesn't count since multiplying by 1 doesn't change anything. And over on the other side, we only have a denominator of 1 and a denominator of x minus 5, because here there's really not a whole lot of variety. The lowest common denominator in this case is simply the x minus 5 expression. And just like what we did with linear equations, we're going to multiply the entire equation by the lowest common denominator. So I'm going to just begin by saying this. And I got more room on the right side, so I'm going to say x minus 5. I'm going to multiply everything in the problem, or in those brackets, by x minus 5. So here, 10 times x minus 5 is going to be 10 times x minus 5. Now, why don't I multiply that through and say 10x minus 50? And the reason is so that way we can see what can we simplify from top to bottom when I have a common denominator for everything. So that's why I'm not multiplying through in the parentheses and x minus 5 in the bottom. And so here, plus this x gets multiplied to the x minus 5, so that's going to give me x times x minus 5. And that just has a denominator of 1, so I don't need to write that. And equals 1 times x minus 5, well that's just x minus 5. And finally, the 2x times the x minus 5 will be plus 2x times x minus 5 over x minus 5. So here, let's move our way back over to the left and work our way through the problem. The whole reason why I left the 10 factored out of the problem is so that way we can clearly see these are factors that can simplify to just give me a 10. Now here, if we want to, we can distribute at that point and say that's going to be plus x squared minus 5x. Here, there's nothing to distribute, so let's just go ahead and drop the parentheses, x minus 5. And here again, we can see the factor simplifies. So now I'm just left with a plus 2x. And at this point, we're pretty much in a much more comfortable zone because there are no more fractions with which to work. Now we do have our largest term to be an x squared term. So this is going to give us something quadratic, so let's put it into standard form. Since the x squared is on the left side and it's positive, I'm going to leave it there. I would not want to move the x squared term to the right side because that would just give me something negative, and I really like to have my largest term to be a positive value. So bring the 2x, the 5, and the x over. Well, let's clean it up just a little bit. X squared minus 5x minus or plus 10 will be equal to 3x minus 5. Let's just combine our like terms on the right side. That'll make it a little bit easier. So we put them in kind of in standard form on the left side in descending order, and same thing on the right. We're just simply cleaning it up a little bit before I move everything over. So if I move the 3x and the 5 over, I'm going to get x squared minus 8x plus 15 to be equal to 0. And now we can solve this by factoring. And the factors of 15 that can combine in such a way to give me an 8 would be a 5 and a 3. Since this is negative and this is positive, that tells me both of these have to be negative, so 5 and a 3. Now I can set each factor equal to 0, like we did in our earlier lesson, and this is going to be x is equal to a positive 5 and x is equal to a positive 3. So those are the two solutions that we get when we do the algebra. Now, the last thing we want to check, because, and this is really one of the only two types of equations that we're going to have to check to see, is it a good, are both of these solutions good? Let's look at the expressions that we have in the denominator, the x minus 5. If I set that equal to 0, well, that tells me that x in this case cannot equal 5 because all we're doing here, let me write what we're doing here. Here we're checking for extraneous solutions. All we're doing is we're taking the x minus 5 from the denominator of the original problem and we're saying, well, x cannot be 5 because if I put a positive 5x or a positive 5 in here for x, that's going to give me a 0 in the denominator. So that tells me that this here, where I have 5 is equal to x, this guy right here is going to be an extraneous solution. So the only real solution, the only one that really works, is the x is equal to 3, whereas this one right here, that's an extraneous solution because it would produce a 0 in the denominator if we substitute it into the equation. Okay, so here, this one actually isn't going to be too bad of a problem. If we look at all of the values in the denominator, here we have x squared on the right side of the equal sign, and on the left side we have 5x and 2x. So if we look at all those things, the lowest common denominator, if I try to if I multiply these two here, that's really just going to give me a 10x squared. And since I already have an x squared term here, all I'd have to do is multiply that by 10. So the lowest common denominator is going to be 10x squared. So multiply the entire thing by that. And now here, because this problem is a slightly bit different because than the last one, because the denominators, even though they are a rational expression because the variable is in the bottom, it's just a single term rather than something plus something else, like in the previous problem. So here we are going to just go ahead and multiply through and see what we get. So the 10x squared times 3 will give me 30x squared over 5x, and minus 1 times 10x squared will just be 10x squared over 2x equals 10x squared over x squared. And I think some of us by now are going to kind of see why that worked out to be the lowest common denominator. The 5 and the 30 simplify to be 6. This x and an x in the numerator simplifies, so I'm left with just 1x. Here, 10 over 2 simplifies to be 5, and x squared over x simplifies to just be x. And here, x squared and x squared completely simplify to just be 10. And so this one's, again, not so bad. Combine your like terms on the left side, and we just get x is equal to 10. So is that a good solution? Well, all of these are just single terms, 5x, 2x, and x squared. If I set any of those equal to 0 and I solve for x, I'm going to just be either dividing by 5 into 0, or dividing by 2 into 0, or taking the square root of 0. So the only thing that x cannot be for these problem, or for this particular problem, is 0. So that works out pretty well. So there's our solution. X is equal to 10. Now, out of the examples that I'm going to show you guys, I'm dead serious. This is going to be the one that has the most challenging algebra to it. And again, I'm not trying to say that to frighten anybody, but there's because there's more algebra, it's not beyond your ability to do. It simply gives you, the more operations that you take, simply gives you the more opportunities, unfortunately, to make an error, make a mistake. You multiply wrong, you miss a sign somewhere, and it can throw the entire problem off. And because these can take a little bit of time, it might cause you to get frustrated, and I don't want you to do that. So when you approach a problem like this, please just be methodical, take your time. It may take a little bit longer, but if you do it at a slow and methodical pace, then you should be okay, and limit the amount of mistakes that you might make. Now, if you notice, the far term on the left has a denominator of a quadratic. And in order to identify what the lowest common denominator is, I must factor that. Now, the nice thing is, problems like this are almost always set up that we don't really have to think about what the factors are. They usually give us the factors of the quadratic in the other terms. So the 2n minus 1 and the 3n plus 1 are factors of the 6n squared minus n minus 1. If we multiplied those two together, that's what we would get. So we don't really have to think too much in order to get the factors here, because the problems are almost always set up that way, that if I have a quadratic, the other two expressions in the denominator will be the factors of the third one. So I'm going to break up the quadratic into the 2n minus 1 factor and the 3n plus 1 factor. And if you just want to pause and check it real quick, FOIL those back out and prove to yourself that they are indeed the factors of the quadratic. So plus the 3n over 2n minus 1 equals the 4n over the 3n plus 1. So here in the expression on the far left, it has both of the linear expressions, whereas the term in the middle has just the 2n minus 1, and the one on the right has the 3n plus 1. So here, our lowest common denominator is going to be the combination of both of the expressions, 2n minus 1 times the 3n plus 1. And this is where things are going to start to get a little complicated. I'm going to try to limit the stuff I have on the board so it doesn't become really messy. But we're going to multiply that entire thing by the lowest common denominator, the 2n minus 1 and the 3n plus 1. That is the lowest common denominator. Now, instead of actually writing it out each and every time, because that's going to cause things to get a little messy, we can see the 2n minus 1, if I multiplied it through the top of the first term on the left, the 2n minus 1 here and the 2n minus 1 here would simplify to be 1. And the same thing here, this 3n plus 1 and this 3n plus 1 here in the LCD they would simply simplify to be 1, and I would be left with just the negative 18. Now here, in the middle expression, the 2n minus 1 here and the 2n minus 1 of the LCD would simplify, but that would mean that the 3n plus 1 is still going to multiply here, okay? And for the time being, I'm going to keep it in factored form, just to keep it a little cleaner for the time being. Same thing with the expression on the right. The 3n plus 1 in the denominator would simplify with the 3n plus 1 of the LCD, but we still have the 2n minus 1 that would get multiplied to it, so equals 4n times 2n minus 1. Now, I hope I haven't really lost anybody yet, but by identifying the lowest common denominator at this point right here, we're pretty much set as far as the rest of our operations are concerned. Because there's no more problems, or there's nothing left in the denominator besides ones, everybody should be much more higher comfort level with these types of problems. So let's start distributing. The negative 18, there's nothing to do with that right here, but here, let's distribute in here, and that's going to be plus 9n squared plus 3n equals, distribute here, and I'm going to get 8n squared minus 4n. Now, the largest term in the equation right now is the 9n squared, the positive 9n squared. So because that's the biggest one, we're going to take everything from the right side and move it to the left side. So that way the largest term is still positive. And we'll do the 4n at the same time. Okay, so that's going to give me here a single n squared term. This is going to be 7n, and that's 0 and that's 0. So putting it in standard, oh, well, let's just take the time and write it out one more time. So this is going to be plus n squared plus 7n equals 0. Let's put it in standard form where it's in descending order of the largest exponent term. So n squared plus 7n minus 18 equals 0. And we're almost there, guys. Just bear with me a little bit longer. Factor the quadratic so we can see what the individual solutions would be. So n and n. The factors of 18 that can combine to give me a 7 are going to be a 9 and a 2. So I'm going to say a positive here and a negative here, since the middle term here is positive, but this one is, the C term is negative. So I'm going to say plus 9 minus 2 here. Excuse me, I'm hoping that's not coming up too bad. I have a little bit of a cough. And now that I have the expressions, or the factors, set each factor equal to 0 and solve for n. So here I have n to be a negative 9, and here I have n to be a positive 2. Now, the only other thing that we really need to check are either of these an extraneous solution, meaning if I put them in if I put them back into the problem, extraneous solutions, will it create a 0? So the two factors that we have in the denominator are 2n minus 1 and the 3n plus 1. So here, 2n would be equal to 1, so n, in this case, could not be a 1/2, and 3 equals 0. So here, I get a negative 1, and so here, n could not be a negative 1/3. So those are the only two numbers that would create an extraneous solution. So both the negative 9 and the positive 2 work. They're good solutions. Now, if you've made it with me through that point, that might be a good place to pause if you need to, but we have two more examples to work through, and fortunately, these are much simpler. Now, these harken back to the literal equations that we saw earlier in the curriculum. because there's really no numbers here. We have, they're definitely rational because all of the variables are in the denominator, but if you notice, they're telling us solve specifically for the variable z. So the lowest common denominator for this particular problem, since all three terms are different, they all have to be multiplied together, so the lowest common denominator is x, y, z. All three terms are multiplied together. So let's put that in parentheses or brackets, whatever you want to call them, and multiply x, y, z. Now, this one's not going to be bad if we just multiply everything through. So I'm going to have x, y, z over x minus x, y, z over y equals x, y, z over z. And we can see this x and this x simplify to be 1. This y and this y simplify to be 1, and this z simplify to be 1. So I'm left with yz minus xz equals xy. Now we're trying to solve for z. On the left side, both of the terms have z, so it's common between both of them, so we can factor it out, and I'd be left with y minus x equals xy. So now the expression y minus x is x, make it look like an x, is multiplied to the variable that we're solving for. So here, those would simplify, and I would be left with z is equal to x times y over y minus x. And that would be it for that one. Final problem, not too challenging here, and then we're done. Again, another kind of literal equation. Really, this one isn't a rational equation at all because the variables are, none of them are in the denominator of the fraction, but we'll go ahead and solve for g here. So I'm going to just give myself a little room. I'm going to write the problem one more time. G times t squared. And so you can see, again, this is where in the problems before, when we had a literal equation, I would explain to you, we'll just get rid of the fraction by multiplying both sides by the reciprocal, multiply everything by 2. So let's kind of do it like that. Multiply everything by 2. So here on the left side, I get 2 times s. 1/2 and the 2 here simplify to be just 1, so that gives me g times t squared. And since we're looking for g, divide both sides by t squared, and that will give you g to be equal to 2s over t squared. And that's it for that one. So I understand that rational equations, rational functions, when we start talking specifically about functions, those are going to be slightly challenging because of the fact that the denominator has your variables in it. But it is not outside of the realm of possibility for us to do it. We have the skills. We just need to have the patience in which to use those skills. So thanks for watching, guys. If you have questions, make sure you bring them up to me in class, either during class or in tutoring or something, and see you guys soon.